Yeah.
So 25 का जो डेट है ना 24 25 ये है
Yeah.
एक हाँ
Sure. Yeah. Yeah. Sir.
ये ठीक है
Correct.
ये ठीक
Date 2025.
हाँ ये कुछ गलत लिखा हुआ सही फाइल है So very good morning to all of you, and this particular training is extremely important because this Brahma model that all of you now know that it was it's an effort of a very long period, and in with support of Brahmaputta board we have worked, and that we have developed this model. Before that also a lot of works were going on that line, that is how to do mathematical model, how to study the river, and we are developing like we are doing with various river training work in the river, and then for that we always do model study. So for various purpose we do model study, for what kind of purpose actually the model can be applied, all those things we can see when we beforehand, and then we can implement it in a better way in the river. Okay, actually probably many of you have heard that there are models like other models also. Hackres is one model developed by US Army Corps. Similarly, Mike is another model which was developed by which is developed by DHI, Danish Hydraulic Institute. So that way, different models are there. Okay, CC2SD is another model globally, but India we do not have that kind of software. Though we were working, not only me, many such researchers are working in hydrodynamic modeling of river. Maybe some of you are also working, but we do not have a we didn't had a software of this kind. So we thought almost 20, maybe more than that, almost 30 years back, we thought that this should be, we also should have a model. Otherwise, what is happening? We are working, we are publishing those things, this is fine, but then people in general cannot apply. And then when software from other institute or developed by US or developed by Netherlands, when these are being used, then when we have some problem, our people do not understand what is going on internally. Another reason is that if our in India, our actually in many of those institute also, our Indian brains are working. I mean, from India, people are going there, they are working there. But if our young generation just started using only software, then there is a problem that later on, suppose what is their internal things and all those things we may not be understanding. But again, to apply, all may not be expert in these things. We'll have to have the skill of applying the software also. But today's workshop is of course for developing that skill of applying again Brahma model software. Okay, not to go very in depth into those mathematical formulation and all those things, but at least as it is developed here, we are here very near to you. So any problem arises in different models, when you apply you find various problems. So any problem arises, that we can have the solution quickly and we understand what is the problem. Otherwise, internally, if you do not understand the things, then you may not be understanding what the actual problem is. Okay, so that way this particular model concept started long back, and then step by step it was developed. Then we published it in different journals, internationally accepted. After that, we have taken it to a software form, and then now it is in a form of a very user friendly software, and that will be giving you the training. And this is first that why actually we go for modeling of river. That what I have told is that the same thing we are pointing out here one by one. That is, when flood comes, what will be its impact? Suppose some of the flood, 100 years return period flood, suppose that we have not seen here, we have not seen that kind of impact. Maybe 500 years return period flood. If that flood come, what will happen? So that kind of things. If the drought comes, low flow happened, then how our reservoir will be serving, how our reservoir will be working, where what kind of problem will be facing. So that kind of thing, whether in the low flow, again, suppose sediment comes in the river, then whether sediment deposition will be there, what kind of things will happen. Okay. So then what will be the impact if any hydraulic structure is made for our need, like spars or navigation also in a channel, whether we can have a navigable channel in a particular portion. So how can we control the river's adverse impact by river training work and so on? I mean, we can keep on going the different kind of works. We need the model. So basically, we need to model. We need to do model study to know the impact of river on us. That is the very basic point that we need that. But then when we are saying us, nowadays, earlier only we were worried about the human being, but now with the term us, we not only include our human being only, because us means there are flora, fauna, various things are there. So how those will be affected, and so all those things will be, I mean, including in our model. So in our model, if we reduce the flow, then, or if we increase the flow, what will be the fate of the aquatic life? That kind of study also we can conduct. Well, so basically, the modeling needs arises when people suffer. This is one thing. Then the question comes that, as I have already told, that Hectress is there, Mike is there, all those things are there. Then why we need our own model? That question I faced not today. 20 years back also people were asking me that, Professor Sharma, why you are developing your own model? Then, in fact, in a very big meeting in Delhi also, I was asked that why we need to have our own model. Hectress is there, Mike is there, we are purchasing those things. Why we need to develop that? So, whatever I have told at the beginning, that was the common answer for me, that we should have our own model so that we have more flexibility on it. This is one point. But sometimes I always give another example also. When we have Hyundai, when we have Hyundai, I don't know who is manufacturer of Hyundai. It's, we have Honda, Hyundai, different things, but we have Tata also. Well, so why we need that vehicle? Because vehicle was not first developed by India. Vehicles were developed by other countries, and then if we would have stopped there, then what would have happened? So now, why we need our own satellite? That is also one point. So like that, when others are developing, fine, but India should not fall behind. We should move parallel at least, and then only with our manpower, if we concentrate on our work, we'll be able to make it even better than others. So that is what I believe very strongly, and that was the answer, and accordingly ministry agreed to that, and then they provided the necessary fund for development of this as a Brahma model, and the name was also coined in an Indian flavor, that Brahma, which is basically, of course, braided river aid hydromorphological analyzer. Okay, so that way this is coming. And then what are the other advantages that we have, and what is the need on that? If we come, that because of high population, like in western country, first again, rivers are also different. I mean, the kind of braided river we have now, again, just few days back we had a discussion in Germany. They are developing another model called Telemag. They also didn't have a model. So they developed another model called Telemag. They are also focusing on addressing braided river, because braided river characteristics also slightly different. But then it is applicable for any river. I mean, when it is applicable for braided river, it can be applied for any meandering river or any other kind of river. Okay. So, but then in our Indian population is so high that almost in any part of the river, any reach of the river, whether you talk about hilly terrain, floodplain, anywhere, we have population. We have a office. Water resource has office in some place. Brahmaputra board has office. Then various organization, NIS also have different part. So that way various organizations have office. So that way engineers are there. General people are also living. Common mass people are living there. So they are facing problem with the river. That's why they have witnessed some of the problem which other country people may not have witnessed. So river, how it behaved, some kind of things. At least we got information of this kind of problem from our very indigenous people, from our interior village. We got that, okay, this kind of things are happening. So large deformation is, then another humble that is called, when the river moves for sometimes it stop again and then again moves. So these are braided river characteristic. So I mean, this kind of phenomenon we are observing. So those kind of phenomenon, if we want to model, definitely we need to first have those kind of problem and we have to address those problems. Otherwise, many other, when I first made it in an international presentation long back, 10 years back, I made a presentation in international forum on that, and then I was explaining about that Hamal problem. That is, the river in a channel, you will find that it is moving, and then you are observing a velocity, but for some time it will stop. It will stop, you will find zero velocity. And then again, after some time, it will move. So that phenomenon was not observed by any of the hydraulic person, any of the river engineers in that forum. So they were quite surprised. Then I said that it is because of the braided characteristic. Two channels are suppose emerging from one channel, and again it is joining at one. So what is happening? This channel is mixing with this channel, and then sometimes what happens, this channel strength is more, it keeps on fluctuating. This water is coming from this side, this channel, and it is getting this as an obstruction. Sometimes it become almost right angle obstruction. Then what happened, to overcome this point, because of this flow is high, so it cannot just move into this directly. Then what happened, the water gets stopped here, and just like in a breeze or any barrier, if you stop, water level will be rising. So water level on this side slightly rise. It is very, I mean, you cannot observe it. If you do not measure, you will not observe it. So it is slightly rising, and then it is gaining some potential energy, because you know that energy is equal to kinetic energy, that is because of velocity as well as because of height, how much it is rising. So it gradually rises, and then after, that's why for some time it is stopping, the accumulated water is coming, and that way its potential energy is increasing. Then it overcomes this energy and it start moving. So when it is moving, again this become obstructed. That channel will stop for some time. So this is just, I mean, happening in some of our rivers. So those phenomenon also we have tried to model in our system. Of course, in the present form of Brahma model, we are not giving all those things. I mean, these are of course in research level, but then for our day-to-day work, what is required, that we will be giving the training. Okay, so this is what I am just presenting in this particular slide. And then again, say in our river we are putting a reservoir. Okay, so reservoir will be operated, water will be released, and then this is moving through the river. Now, reservoir operation model is different and river model is different. Now, if you have indigenous model, we will be having a scope of combining two model to have a more user-friendly model. That kind of things also we are doing. So that is another reason why we need our own programming, own model, why we need. Okay. So that's the why we need the, I mean, need to have our indigenous model. Okay. These are some of the example I was giving. That is, for example, coupling reservoir operation model, which river model, coupling, confluence modeling. In the confluence, thus I have explained confluence modeling, which aquatic behavior, how aquatic behavior will happen there. So analyzing impact of vegetation on flow characteristic. So these are just some of the example. There are, I mean, I can keep on going giving example after example where actually we need our indigenous model so that we can combine them to have better understanding of the situation. Okay. So Brahma model include now say simulation of vegetation, simulation of porcupine. I mean, water resource department probably, or you have seen porcupine, it's not in a tripod. But if we put a porcupine in the river, how we will be modeling that one? Okay, its effect. Now, many a time people change the resistance, but then this is just arbitrary. So we again with Brahma model, we did some collaborative work with water resource department, and then that work has also been published in International Journal of Hydraulic Research. So that has been published, that how actually this uh, porcupine, if we put, depending on this length, depending on this dimension, how actual resistance will be developed, and then how it will be functioning. So that kind of things we could do only because we have our indigenous code, we have our indigenous program and the model. So that way, actually model is nothing but it is basically solution of governing equation, and then that we do by various numerical method. We can have different kind of numerical equation, numerical solver, a numerical solution, but then with that advantage we can do it. Similarly, morphological change also we are doing, but in this version we are not putting it yet. So that way, we are now just briefly describing. In this particular program, we'll be giving you the training, hands-on training, and that's why lecture will not be there in this particular program. Lecture means only this lecture. Others will not be lecture. They will be our actual researcher who are working on this. They will be showing you the hands-on, and you will be actually working with your own system, and you will be in a position to run the model for your problem later. So that way, and then you will be practically doing it. So we are doing with Brahma 2D. Once you do the 2D, later on 1D will not be a big problem. So that way we have, because time is short. We thought of giving a training for 5 days, 7 days we were discussing, but then it is very difficult to get that time. All of you are very busy with your actual work also in your office. So that way it was decided that 3 days, but then we'll concentrate on Brahma 2D. Okay. So this Brahma 2D, just for your information, though we will not go in detail, but basically all such river models are solving two or sometimes three equations. These equations are very basic equation, like our three physical equation of what are those things. Conservation principles, three are conservation of mass, conservation of energy, and another is conservation of momentum. So basically these three, but then here we are using conservation of, again then equation wise, when we do conservation of energy and conservation of momentum, we can arrive at the same equation also. And then conservation of mass is basically continuity equation. Okay, so though you will find that here this equation how it is, because somewhere if you see, you should understand this is written in a metric form, that is u to t. Okay, u to t means it is basically t is the time, so it is partial differentiation with respect to time. Basically it is del u del t kind of thing. Partial differentiation with respect to time. X represent partial differentiation with respect to x. Okay, so y represent like that. Partial differentiation with respect to y. That means if we consider that, I mean, the longitudinal direction of the river is x, then this is, say, lateral direction is y, then how these velocity or different things are changing with x, y, and t direction, and then it will be equal to some source term. Sometimes it can be zero, sometimes it can be a different value. So source means basically we are talking about, okay, I'll explain with this equation. So, like that. Now, here you see, when we say mass, basically mass is equal to, if there's a density term should have come here. But then you can see the rho or density term is not coming. The reason here is that we are considering the water to be incompressible. See, water has a particular density. If it is compressible, if we compress it, its density will increase. If we expand it, its density will go down. Then the density becomes a variable. In gas, we cannot consider rho to be constant. But in water, we can consider the rho to be constant, density to be constant. So as it is constant, if you differentiate, it will have no meaning. So we are actually eliminating rho from all. Okay, this is very common equation. So from that, actually again, this is coming that depth Here h is depth, h u is depth into velocity. This is making actually unit discharge kind of things in x direction. This is unit discharge term in y direction. Okay, so this rate of change of depth, rate of change of unit discharge, rate of change of these things, finally this is equal to 0 means we are basically conserving the things. Okay, so the mass is conserved, basically volume is conserved here, because rho into volume is actually mass. So rho we are just cancelling, because on this side we are cancelling, so that way this is what is making the answer. This is form is called matrix form of writing equation. Means actually this u2 we are writing here, and this is having three terms, here also three terms. That means this is making, first row is making one equation, second row is making another equation, third row is making another equation. So this is the equation. From that we can find that this plus this plus this plus this equal to 0. So that way we are making the equation, writing the equation in simple form. Now, when there is a h means the depth, but in braided river, as you know, that depth will be quite undulating, and then your depth means, suppose water surface will be in the same level, more or less. I mean, this will be changing, but then it will be in the same level. But bed will be somewhere, it will be sandbar there, somewhere it will be deeper portion. So if we take depth, it is changing a lot, and it create a lot of problem in, and solution of this equation is very difficult, because a numerical solution, when you go there, if there is an abrupt change, then it create problem. So we have transformed this equation into the form of surface. It is not visible that much. That means with respect to, rather than depth, we are talking about the surface level. Surface level, and then other discharge terms is remaining same. So that way it was transformed, and that equation is solved by one of the method. We actually tried different method, and solution also obtained different way, but then we found that this method is okay. Though simple, we can solve this easily by this method. So we have gone from a Chromac DVD scheme, and that way it is being solved. Okay, other methods are also there, but sometimes those take more time, so we are solving it by that. Well, now this you can see that this I have shown in various places. Oh, the cursor is not working here. Oh, so this is a place near Majuli. If you are going, these are the spar. How we implement that? This is the grid is being made, and then in the spar portion, Majuli, there are four spar actually. So this spar we will have to raise the level, and accordingly we made the spar. So the grid is there. Every grid we are giving the elevation value. That the spar is made. Now when we run this model, then it will show that you can see the flow is coming, how it is deflected, how it is going, and how it is reaching the sandbar, and then we can visualize the flow very well, and then we can understand how we should protect and what kind of things are happening. So this is just one example of a model. You will be developing those models yourself now, and you will be running similar kind of work. Now, similarly, you can see that if you give a spar here, how actually this is, we did extensive field data collection from all these spars here, and then for validation of the model. And those velocities were measured in all those points. And then this is what I have already shown you, how it is running. And then you can see that how the velocity will be changing, how the whirlpool will be forming, because a lot of whirlpool happen from there, and the large ET kind of things. This is creating a lot of scouring here, and that's why many a time our spar nose fails. So people feel that okay, when nose is given, and this kind of field survey was done, data were collected directly from the river with a lot of effort, and many a time people blame that okay, spar is given, apron is given, but nose is there, but it is failing. So people think that, well, it is they try to blame the engineers. Generally, our civil engineers had a bad name also sometimes, huh? So because of that, people think that to कुछ गड़बड़ हो गया इसमें, हाँ? ऐसे कि civil, I always used to give an example that people earlier used to, whether you know or do not know, I do not know. How many of you are civil engineer? Okay, all are civil engineer. Okay, civil, CIVIL. that civil, there is an abbreviation for that. People used to give. What is that abbreviation? Anyone know? CIVIL? You don't know? Okay, this was a very popular abbreviation in our time. So when we were studying civil engineering, then a abbreviation was given that CIVIL, corruption is very important in life. So that was the abbreviation given for civil. That's why CIVIL, corruption is very important in life. So because people of course, this is also a social problem. When you are an engineer, if you are working in a village, from a village, people will have a lot of expectation from you. Okay, lot of expectation will have. बिहू किसी ने पता मनाया तो पूजा मनाया तो संदा के लिए आ जाएगा बहुत सारा problem है social problem is there but then because of that actually nose is failing but actually nose is made for apron is made that it will be launching and then when it is launching you will have to refill it but this is not that बार बार दे रहा है तो वो गलत है ऐसा भी नहीं है but then you will have to make people understand that it is like that but that you will be able to do only when you are confident about that थोड़ा सा लेकुना है थोड़ा सा अगर किसी ने कुछ पूजा में चंदा दे दिया तो भी थोड़ा मन में वो रहेगा ना so then you cannot explain that why it is happening but that's why then I created another definition of civil maybe that also 20-30 years back that I said that no that is a wrong definition of civil CIVIL, we need to change. It is that creation is very important in life. With that motto, I started creating this Brahma model and I'm trying different things. And many are working on that part with that motivation and that way we are having. And then in river, why I just brought this point? When this whirlpool form, and then otherwise also in the river, the surface velocity is low in this kind of river, in braided river, surface velocity may be low and then bottom velocity may be very high, as you can see. This is a vertical velocity profile. So this vertical velocity profile, we have developed some quasi 3D model also, which is not beyond the scope of today's training, but we have done it. But if you see that is actually like this. So if you are designing the velocity with respect to this one, but not with this one, bottom part will be scarred and the velocity is also high. So this understanding is also necessary. So many 2D model will not give this kind of things, but we have the understanding. Now, suppose you are making the 2D, that 2D average velocity we can take, and then taking that, we can find out surface where the maximum velocity is there. Accordingly, we can develop this one. That is, of course, not within the scope, but then I am giving you a general idea of what is there. And this work was done, and this work was actually rewarded also. For that, we got, reward also in 2023. In 2023, we got that award. So that way, these are gaining popularity. People are knowing that okay, this kind of works are going on. Okay. Then similarly, same model. Earlier, it was this is again another application. This is a tiding river in the border of India, China, Arunachal Pradesh. So there are, if you see, this is the Lohit River, main Lohit River, and this is another tributary called Tiding. And road need to cross this Tiding River, then again Lohit River, and then it is moving toward China. Now, whatever breeze you give here, it was always failing. I mean, till the work was referred to us, there were 4 cases of breeze being washed. 4 cases. 4 times the breeze was given and it was washed. So then they approach us that, okay, can you just see what is the reason that we are constructing in Greece, particularly military people, border organization approach us that why it is happening. They have tried here, they have tried this place, they have tried in different place, but then 4 times the breeze was washed. Because when they go and measure the velocity, suddenly, I mean, they do not know what happened. That suddenly high velocity comes and then it creates problem. So there are actually some upstream there kind of natural reservoir kind of thing, and from that sometimes heavy water comes and then design was actually underdone. I mean underestimated kind of thing. So then we took this problem and we applied the Brahma model here also. That was again long back, not now. Because Brahma model actually the work is going from long time. Now we are coming into this stage, but then this work we did in maybe 2008 or something. So exact year I am forgetting, but then during that year. Then it is you can see that this river was modeled, and then we could see that there is a narrow portion, and then in this portion, very and apparently, if you see that this is a flat kind of thing, as if the river is moving over a, I mean, over an area which is like paddy field kind of things. It is appearing, but it is not. This between this river and this portion, though it is looking like a flat, but it is very high elevation. River will not cross to that level. So many a time without going to the site by DM simply if you do without going to these things, then there is a problem. I mean you may not get the exact I mean bathymetry or exact shape of the cross section. So people think that water will be flowing to this side and that way velocity will be going down, but it is not like that. It is going this portion, and in this portion the velocity, as you can see, this color will indicate that velocity is very high. Here you can see the velocity level, flow depth is high, velocity also is plotted somewhere here. Oh no, here vector value is there. So velocity also become very high. So when the velocity become very high, if you put a breeze here in between, in the breeze, if you give this and that, so that exercise we will be doing here also. Not with this river, but in general, Siam river will be. Like if you have a pier, so around the pier the water will be actually circulating. Okay? I mean it will be moving like that. There is a concentration of the flow line. That the velocity become high and it starts curving. Now when you give in this kind of river, when you give one piers here and another suppose abutment here. So that way when the water moves, when the high volume comes, then the velocity becomes so high that it's covered a bed and then it just was away. Years and according to the scholars. So after doing all this analysis, we found that if we do not put a pier, solution is simple. If we do not put a pier in between, but we make a strong abutment, and if we connect, and then we will have to protect the bank. It is easier to protect the bank. It is easier to protect the bank. So if we protect the bank with boulder riprap kind of things, and then abutment is far slightly away from this, because this kind of span is possible in one span. So we suggested accordingly they made the bridge like this, and till then this page is working there. So that problem was resolved. So when we have our own model, we can look into those things in a more clear terms, and we can provide the solution. Well, then this is another example I am giving, the eco-hydraulic application. Jorhat district, Bhugdoi river, there is one river called Bhugdoi. This is very famous for one fish. That's why I was talking that aquatic system or aquatic different yeah, fish and flora and fauna. So there, one very popular fish is Hangun fish they call, but it was disappearing from the river. People found that I mean this flow is now they do not get that much of fish. So then we run the model there in Bhugdu River. It looks like a person sitting, but it's not that the river shape is like that. So we run that model, and then flow depth control from the hydrodynamic computation in Bhugdu River here. So how the flow depth is there for different situation, that we did. And then after that what we are finding that uh, that means for fish habitation, that let me tell briefly that fish habitation for a particular species, they need certain depth. They need certain depth. If that depth goes down, or if that depth even increase, then that area will not be suitable for. So that's why we are giving emphasis on this depth. With different research we run it, and then we found that there are different depth available at different portion, and that way we could calculate what will be the habitat suitability of this river, how much suitable habitations are there for that particular place. Then we found that actually habitation area is reducing here because of a project upstream. So if we just regulate that properly, then we can maintain that habitat area, or if we can again maintain that habitat area by some small wear kind of things also. some measures can be taken, but then habitat area suitability, if you see that weighted usable area, what is written here, weighted usable area is basically changing weighted usable area and total flow area. When the river flow is increasing, your total flow area in the river, total flow area means cross section I am talking about, entire area, total flow area is increasing, but your habitat treatability up to this point, if the flow is very low, then also your habitat treatability is not that much. So fish is not finding very comfortable there. Up to this much, it is fine. But beyond that, again, the habitat treatable area goes down. So we need to maintain at a particular level, then only we can have this. So this kind of study also we can do when we have our own model. This work has also published in ASC, American Society of Civil Engineering Journal. This has been published. So that way, I mean, these works are being appreciated about this our model and how we are applying this model to different scenarios. So with that, we are gaining more and more confidence, and we are going ahead. And then finally, this is another point, that vegetation. If we put vegetation here, this is just I'm showing in a rough drawing. This is the vegetation. If we put, then how the velocity goes down, because our model can simulate velocity, I mean impact of vegetation on the flow. Okay? So this vegetation can be again considered as rigid vegetation. So vegetation is not flexible. Sometimes we can consider as a flexible vegetation. The flow is coming, vegetation is also flexible. So for both the cases, there will be different formulas and different things. So in our model, we can do that. That is included here in this training. So vegetation model is also included. So because nowadays by nature-based solution we are trying to solve the problem, and that way these kind of things are being done. So vegetation can reduce the velocity without flow velocity without bank vegetation. This is the blue one. With bank vegetation, this is going down. Okay. Similarly, we can see a turning also if we put vegetation, what is happening. But that way we could see initially. Then this work was also published and then in a Springer journal. So then we could see that again, as I told, that porcupine. We can always give the porcupine in different way. Say porcupine, this is the full form, but then sometimes it is this part is supposed emerged. I mean, this is outside the river level, and this is only in the bottom portion. Then how we can do the area that will be obstructed by the porcupine. So this is again image processing kind of thing that also will be giving you the training here how we can apply that. Similarly, vegetation. This is also that a part of this can be above the water level, some of this can be below. So accordingly, how we can find out different in our model real system, just you take the photograph of the vegetation and you just analyze that, and then you can find out how much actually area is obstructed. So that way you can see that this is the area obstructed by the vegetation, this white patches are, and accordingly you can find out I mean what will be the resistance offered to the flow. Then you can find out that whether there will be sedimentation or not. You can have an idea at least. So there is modeling impact of porcupine and vegetation also we have done, and that way this work was also actually for Majuli, as I told that with water issue department we did with porcupine, and this part was validated there and this part was checked, and that way this work has also been published. As you can see, the name of water resources engineers people as well as our people, I mean our researchers. So it is basically a collaboration between water resource and IIT Guwahati, and then Brahmaputra. See, it is a collaboration. Of beauty is that it is a model is being developed by Brahmaputra board and IIT Guwahati, and then we have collaborated with water resource also for practical implementation. So that kind of collaboration is extremely done. I mean, at a very, in Japan at least they do that kind of collaboration. In Western country also they do that kind of collaboration. But in our country somehow this collaboration is missing, and we are doing this kind of collaboration, and that way this on this side also we are advancing. But otherwise, researchers keep on doing those things in the, I mean, in the lab and this kind of thing. field engineers keep on doing those kind of, so whatever they give, they do not understand. Whatever they say, they do not understand. And whatever field people say, researchers do not understand. Whatever researchers say, field people do not understand. Do not understand or do not appreciate, both way. So I mean, if there is a collaboration, then we'll be able to understand our river in a better way, and we'll be able to provide better solutions. So that way, these things also are being done. Similarly, Brahmaputra board, the laboratory setup is there here. In your free time, it may be possible to go, and there also we done the experimental, that kind of in fact facility is not there in many places in the world. I mean, this kind of large facility of river modeling is not there in many places. Pune we have, then similarly, but then some other organizations we have only, but very limited, not everywhere. And so this was again our here also in laboratory we did this modeling. First that we saw the experimental value, and then we model it in our model, and then we tried to see how the erosion problem of some portion in the Majuli and Bhugdoi, it is particularly Bhugdoi side on this side, Jorhat side, how we can control. So those were experimented. Of course, physically whether it is possible to implement, that is again another aspect. So that also we need to look into. So that way, these kind of works are going on. And then just this is of course a different topic, that we develop a method of bioengineering, call it as the MCGPS system. And there just erosion are going on in this form. And then we have tried like this. This is of course not on modeling directly, but then I'll just come to the modeling part. We thought of presenting it in a different way, that like there will be some a cone of wire bag and all these things. This is there, and that way some vegetation will come. So different stages where I'm not going into that in detail because that is not my focus today. So, but then some bamboo will be there with as a wave breaker, and with all these things, when the vegetation will come, it will be withstanding the erosion. And that way we thought we go for the field, and when we go to the field, that means where we can apply, where these applications come. When we went to the field, lot of erosions were there, and then we did the survey, and then we got the velocity actually measured there. And in this portion we thought of applying our bioengineering method. The velocities were measured in a very sophisticated manner. Then we also identified what kind of plants are there in the local area. So all these plants, all these grasses were identified. Accordingly, we made a plan that this will be there. But then what kind of vegetation, what spacing it should be, that is again important. That's why we went for application of hydrodynamic model. There you can see, if we put the vegetation in different pattern, if we put the vegetation in different pattern, this is a square pattern. One plant is here, another plant is here, one grass is. So, but then if we put it in an interlace pattern, these are different patterns. We put it in a hexagonal pattern and connect. Then we apply the formula. Our actually the resistance are totally different. It changes a lot. How much velocity reduction we can do, that was actually tried. And then in this is the portion near bank part of the one Majuli channel. So then we applied our model, and you can see that in square pattern, in interlace pattern, in hexagonal pattern, how with different type of vegetation, say 0.05 meter diameter, very small, with bigger diameter, with different diameters we saw. And then how the square pattern is reducing the velocity by 58%, interlace is 68%, hexagonal is 69%. So that way we decided that how to do the plantation of the vegetation. So model has the provision of understanding those aspects also. So this is again for a different diameter. So accordingly we saw that how the velocity can be reduced in different pattern. So these are the average velocity on how much is the distribution of the actual data. So that is being shown with different diameters. And then we went for actual field application like this. In the field we traced this, how we put the mat, and then how it was laid down, and then how the geobag and coir bag were arranged, how the bamboo pools were arranged, how the actually vegetation pattern were arranged there, and accordingly it was implemented. Plantations were also done with fertilizer, biofertilizer, so that the river is not affected badly. And after doing all these things, I am showing that we had to put a fencing also there, so that the plants at the initial stage is not damaged. Of course, that could have been done in a different way also, but then it was actually done in collaboration with Brahmaputra board, and Brahmaputra board decided to give a fencing like this with our request. So the fencing was given, but still maintaining the animals are difficult. So we'll have to find a better way of maintaining the animal. Otherwise, this cow or this buffalo comes from the river side also. And because then we planted vegetation. Vegetation means we planted 5 different varieties of grasses. These are vetiver, napier, guatemala, and one was birina. So like that, 5 different types of vegetations were grasses were there. Plant also, even we started planting agar plant, because agar plant has a economic value. So if we are successful again in agar plant, whether we will get that particular flavor, it depends on what kind of fungus is attacking that. So that kind of research is also necessary. So but then we are trying agar plant plantation there. In Majuli it is not there. Then other native plant like that various plants are there. I have already shown you the number because many numbers are there. So those were planted, and then gradually when it happened that in the we experienced flood like this on that particular site. This was the first year already. The bottom part is there with all apron and all these things. These are also actually bio related. I mean with coir bag and geobag were also there, and then with bamboo planting. So these are there. Bamboo not planting, actually bamboo post, which is working as a web breaker. So this kind of flood situations where I mean withstand this kind of flood happen. And then this fencing which was earlier, I mean I have shown this is underwater as you can see, but this kind of situation also it has passed, and then we could see that it is withstanding the erosion, and it has that just before our project area is this one, and just 300 meter on the upstream. This is the area, 300 to 500, almost 1 kilometer you can say, because we visited in a flood time, so we had to walk. And so we were working on the upstream. This part where our method is not there, it was eroding, very severe erosion took place. So people were worried, saying that okay, erosion is happening, what will happen? Then we said that okay, it is fine. Oh, no, sorry, flood is coming, what will happen? I said that it is a good thing that we are again getting a opportunity to see whether our measures succeed or not. So that way, this was heavy erosion on the I mean about 500 to 1 kilometer upstream of that area, and then our area is quite safe. So that gives us, this is our area, it is quite safe, and that gives us a confidence that yes, whatever we are working is fine. We visited that area in a very tough time, in a very precarious way. We had to move in a boat, and
এই
then
কামটো নকৰিলে
people
আমাৰ
were
গড় বায়ু
saying,
উঠালেহেঁতেন গতিকে এই কাম বহুত ভাল কাম
so
কৰিছে
that people are saying that this
সেইবুলি
is
আমি
a good
চিন্তা
work.
চৰ্চা কৰিম
আচ্ছা ভাল পাইছে নহয় জানো
ভাল পাইছোঁ
হয়
আমি অজাগত হৈছে এইটো কাৰণে আমি ঘৰ বাৰী ভালকে বনাওঁ
হয়।
বনাওঁ বুলি চিন্তা কৰি আছোঁ নহ'লে এইটো এইটো নহ'লে এতিয়া কি মাহ হ'ল
So what he is
শাওণ
telling
শাওণ হ'ল
that if this would not have been made,
আৰু
this time this
এই
would
কিনিম
have
পাই
gone
যায়
to
নহয়
again
পালে
eaten up
সেইবোৰ
a
আমি
lot of
চিন্তা কৰি
area.
ঠিক
So it is good
তাৰপিছত
that you
ইয়াৰ
are
পৰা
making. So you make it in all along the
উজাই
river.
চাইডৰ
That is his suggestion.
কৰিলে আমি ধন্যবাদ
Finally, that Namaskar is very important for us, because for Brahmaputra board as well as this is one of our joint project, and so that way if we do collectively, I hope that we'll be able to address various problem of this kind of thing. This is just an example where actually in the field it is our model application has given benefit. So a lot of PhD scholars are working on this, lot of project staffs are working, lot of other funding agency also has given support for not only funding agency, I mean collaborative agency. So I always take this opportunity to extend my thanks to all those organizations, my PhD student, my project staff. So all these are I mean appreciation for their work. So thank you very much. Thank you all. This is just the informal introduction of the Brahma model. Now we'll go to actual hands-on. Thank you very much.
सर क्लास हो गया? क्लास हो गया? हाँ हो गया। स्ट्रीम ऑफ कर दे? हाँ कर दे।